Hi everyone, welcome back to College Algebra. Today we're in section R.4 of our textbook and we're going to be talking about factoring polynomials. And this is a super important skill. You cannot go forward in algebra until you learn how to factor. This is the key to everything. So I'm going to start out showing you how to factor out the greatest common factor, and then we'll look at how to factor trinomials, how to factor some special binomials, and then a general factoring strategy that you can use to approach any factoring problem that you have. So here we go. First, let's talk about what it really means to factor. To factor a given expression means to separate it into two or more factors that can be multiplied together to produce that expression. So basically, factoring is unmultiplying. Now, when we talk about factoring out the GCF, what we mean is we're going to factor out the greatest common factor. And this is just reversing the distributive property. So you know how to distribute. When we factor out the GCF, we are basically undistributing. So we're just reversing the distributive property. Now, when you factor out a GCF, there are a couple of things you always have to be on the lookout for. First, always make sure that distributing the GCF back in there will produce the original expression again. And second, make sure that the terms inside the parentheses no longer share any common factors, because if they do still share a common factor, that means that whatever you factored out was not the greatest common factor. G stands for greatest, which means it's going to be the largest thing that we can factor out. Now, here's something else we need to be aware of. If the leading term, in other words, the first term in your expression is negative, then it's customary to factor out a negative GCF so that the first term inside the parentheses will be positive. This is not a hard and fast rule, but it does make the final expression look a little nicer. It makes it a little easier to work with. And so this is typically what we do. If the first term in your expression is negative, factor out a negative GCF so that the first term inside the parentheses will be positive. Now here we go. We are going to practice factoring out the greatest common factor. So notice the instructions say factor out the greatest common factor from each polynomial. In this first expression, we have 9y to the fifth plus y squared. Notice that both terms here contain factors of y. This one has 5 y factors. This one only has 2 y factors. So the largest amount of y factors that is common to both terms is 2. We can factor out y squared. And now we need to put down an empty set of parentheses, and we need to figure out y squared times what will produce each one of these. So we know that y squared times 9y to the third would give us this first term, and then we'd have a plus sign. And we know that y squared times 1 would produce this second term. Now notice that if I distribute y squared back in there, it goes back to this form. But this is considered factored because it's y squared times the rest that's in parentheses. So this is factored form. In other words, multiplication form. Now I want us to look at a common mistake. Sometimes students will say to themselves, well, when 1 is a coefficient, we really don't have to write the 1. So I wonder if maybe I don't have to write the 1 here. So I have seen students work a problem like this by writing this answer. Well, the problem with this answer is if you distribute y squared back in here, you're not going to get both terms back because you only have one term here. So you really do need the plus 1 in order for the distributing to give back both terms. Now here is another mistake that I see students make a lot. Notice in this answer, if we were to distribute the y, we'd get 9y to the fifth plus y squared, which is what our problem said. So if you just redistribute to check your answer, then you'll think you got it right. But notice here that both terms still contain a y, and that means that this y out here is not the greatest common factor. In other words, we could have pulled out a bigger power of y and gotten this answer. So it's really important that you always check that inside the parentheses your terms no longer share any common factors besides 1. Now let's look at part B. Here we have negative 6x squared t plus 8xt minus 12t. Notice that we have a negative leading term here, and so we're going to factor out a negative GCF. So let's go ahead and put our negative here. Now we want to look at each of these coefficients, and we want to think, what is the largest number that will go into all 3 of these coefficients? And 2 is the largest number that will go into all 3. So I'm going to go ahead and put down my 2. Now we need to ask ourselves, is x common to all 3 terms? Here I have x squared, here I have x, but this third term does not contain an x, so x will not be part of our GCF. And now what about t? I have t here, and here, and here. So t is a common factor, so I am going to have a t in my GCF. Okay, now I need a pair of parentheses big enough to hold 3 terms. And we need to go through one term at a time and figure out what would we have to put for each term so that negative 2t times that term gives a term from the original expression. Alright, well I know that negative 2 times positive 3 will make negative 6, so I'm going to go ahead and put 3 there. And I know that I'm going to need an x squared in this term, and I already have a t out here, so I don't need another t on this term. So now notice that negative 2t times 3x squared would produce negative 6x squared t, so that looks good. Okay, now for our next term, negative 2t times something has to give us positive 8xt. So I know that negative 2 times negative 4 would make positive 8, so I'm going to go ahead and put down my negative 4. And now I already have my t here, but I need an x right here. Okay, so now negative 2t times negative 4x would make positive 8xt, which is what we wanted. And for our third term, we know that negative 2 times positive 6 will make negative 12. So negative 2t times positive 6 will make negative 12t. And remember, we always need to check that our distributing works. So just really quickly, mentally, make sure that negative 2t times 3x squared gives you that term. Negative 2t times negative 4x gives you that term. Negative 2t times 6 gives you that term, and that all works. And then, just as important, you need to make sure that these terms no longer share any common factors other than 1. So is there anything besides 1 that goes into 3 and 4 and 6? And the answer is no. Do they all have an x? The answer is no. And of course, none of them have a t. So we really did factor out the greatest common factor, and this one's finished. Here are a couple more examples where we are going to practice factoring out the GCF. On part A here, notice that we have negative 8k to the third plus 24k. So again, we have a negative leading term, so we'll need to be careful and factor out a negative GCF. Okay, so what's the largest number that goes into both 8 and 24? And the answer is 8. So I'm going to make sure and put down negative 8. Now, this term has 3 k factors, and this term only has 1 k factor. So the largest amount of k's that they both have is 1. So I'm going to put k right there. And by the way, the largest power of the variable that you can pull out is the smallest one that they all have. So since both of my terms have k, then I can pull out k to the first because that's the smallest power of k that I have in any one term. Okay, so there is our GCF, and now we'll put down our empty pair of parentheses. It needs to hold 2 terms. So what would I need to get negative 8k times something to be negative 8k to the third? Well, I would need k squared here. And then what would it take for negative 8k times something to be positive 24k? And it would take a minus 3. So that goes there. Now, always make sure that when you distribute your GCF that it goes back to looking like the original problem. And also always make sure that the terms inside the parentheses do not share any common factors other than 1. So we're in good shape there. And let's look at part B here. We have 3z to the 5th w squared minus 18z to the 3rd w to the 4th. And let's look at the coefficients first. So my coefficients are 3 and 18. So the largest number that goes into both 3 and 18 is 3, of course. And now let's look at the z's. Here we have z to the 5th, and here we have z to the 3rd. So z is a common factor, and the smaller power of z is the 3rd. So that means z to the 3rd needs to be part of my GCF. And on the w's, here we have w squared, and here we have w to the 4th. So w is common to both terms, and the smaller power is w squared, so that needs to be part of our GCF. Okay, now I'm going to need 2 terms inside the parentheses. So I put down an empty pair of parentheses. And let's see, 3 times what makes 3? Of course, that would be a 1, but we really don't have to write that coefficient of 1 if we don't want to. And z to the 3rd times z squared would make z to the 5th. And w squared times 1 would make w squared. So I don't need any more w power here. So just verify for yourself that 3z to the 3rd w squared times z squared does equal that first term, and it does. Okay, now on the second term, 3 times negative 6 would make negative 18. Z to the 3rd is already out here, so I don't need any more z power here. And w squared times w squared would be w to the 4th. And so we can see that this GCF times negative 6w squared would produce that. And we also need to make sure that our 2 terms here do not share any common factors other than 1. Of course, this coefficient is a 1, so nothing besides 1 can go into both of these coefficients. Z is no longer common to both terms because we only see z here, and w is no longer common to both terms because we only see w here. So this one is finished as well. Now let's talk about factoring trinomials. Factoring a trinomial is like reversing the FOIL process. You know, in section R.3 we talked about how to use the FOIL process to multiply 2 binomials together. Well, factoring a trinomial is just reversing that FOIL process. When we factor a trinomial, we're trying to find the 2 binomials that were multiplied together to make that trinomial. This is not something that you can just instantly see in your head. You do have to think through a process. It is a learned skill, a lot like learning to put together a jigsaw puzzle. The more jigsaw puzzles you put together, the better you'll be at it. And you just have to learn how to go through the options until you find the one that works. So here we're going to factor each trinomial if possible. Note that not every trinomial can be factored, but most of the ones we will see can be factored. So here I have x squared plus 9x plus 20. This is a trinomial because it contains 3 terms. And we know that to factor a trinomial is to separate it back into the 2 binomials that were multiplied together to get these 3 terms. So the first thing we do is set down 2 empty pairs of parentheses. And our job is to figure out what terms have to go in here so that the FOIL method will produce this answer. Okay, so the first times first gives us x squared. So we know that first times first is going to be x times x. Now, the next thing that I like to look at is the sign of the last term. This sign right here. If this number times this number produced a positive answer, then what that tells us is that both of these numbers here had to be the same sign. But we don't yet know if they both had to be positive or if they both had to be negative. We just know that they had to be the same. So if you have a plus here, you know that the 2 signs here have to be the same. And if they're the same, they both have to be whatever this middle term is. So this last plus sign tells me that I need the same signs here, and this plus sign tells me that both signs here have to be positive. So I go ahead and set down my 2 plus signs. And now it's just a matter of trial and error. I need last times last to be 20, but I need outer plus inner to add up to 9x. Now, I'm being very careful not to say that you need to find two numbers that multiply to give you 20 and they add up to 9. That does happen to be true here, but you can't rely on that all the time. When the coefficient in front of the x squared term is anything besides a 1, that no longer works. So what I want you to do is always think outer plus inner has to make our middle term. Now, what are the factors of 20? Well, the choices would be 1 times 20, or 2 times 10, or 4 times 5. And I need to choose a pair of numbers that when I put them here, outer plus inner is going to add up to 9x. So, of course, 4 and 5 will work. And now you can see that outer times outer is going to be 5x, inner times inner is going to be 4x, 5x plus 4x is 9x, so this factoring is complete. Now you might be saying to yourself, why is it that we only have to check outer plus inner? Well, the reason is because we're in control of all the other numbers. It's just the middle term that we're not completely in control of. We put x times x here because we know that makes x squared, so we don't really have to check that. We already know it. And we used 4 and 5 because we know 4 times 5 makes 20, so we don't really have to check that. The only thing we didn't get to choose on purpose was the 9. So we need to make sure that 5x plus 4x does add up to 9x, and it does, so that's how we know we're in good shape. Now let's look at part B. Here we have y squared minus 7y plus 12. This is a trinomial. So what I'm trying to do is factor it into two binomials. So I'll go ahead and put down two empty pairs of parentheses. Now first times first has made y squared. So I know that what goes here and here has to be y times y. The last times last made a positive 12. So I know that the signs that go here both have to be the same in order to produce a positive for our last term. But I don't know if they should both be positive or both be negative. So I need to look here. And this tells me that both signs here and here should be minus. Okay, now last times last has to make 12. Our negatives guarantee us that we're going to come up with a positive, but what about the numbers? Well, the numbers that you can multiply together to get 12 are 1 times 12, 2 times 6, or 3 times 4. We need to choose a pair of numbers that's going to let us get outer plus inner to add up to negative 7y. So of course you're probably already thinking 3 and 4, and let's make sure that works. Outer times outer is negative 4y. Inner times inner is negative 3y. If you add those together, negative 4y plus negative 3y, you do get negative 7y, so this one is complete. Now let's try a couple more of these. Here we have m squared minus 5m minus 14. So of course this is a trinomial, and of course we are trying to find the two binomials that were multiplied together to make this expression. So m squared has got to be broken down into m times m, and this last sign is minus. So last times last has made a minus 14. And the only way to get a negative number when you do last times last is if these two numbers have different signs. So at this point I know that I need a plus and a minus, or a minus and a plus, either way. All that matters at this point is that we know last times last is going to be able to make a negative number. Okay, now what are some numbers you can multiply together to get 14? Well, your choices would either be 1 times 14 or 2 times 7. And of course, in order to get outer plus inner to add up to negative 5m, we're going to need to use the 7 and the 2. But we need to make sure and put the 7 with the minus and the 2 with the plus, because we need outer plus inner to add up to negative 5m. So notice outer times outer is going to be positive 2m, inner times inner is going to be negative 7m, 2m minus 7m is going to add up to negative 5m, and that's what we wanted, so this one's good. And now let's look at part D. Here we have p squared plus 2p minus 48. And again, this is a trinomial. So we know we're going to try to find the two binomials that were multiplied together to produce this. P squared has got to be P times P. Last times last has made a negative number. So that tells me that the signs here will need to be different. And last times last has made a negative 48. So I think about the factors of 48, and I could use 1 times 48, 2 times 24, 3 times 16, 4 times 12, or 6 times 8. And you're probably already thinking, well, 6 and 8 are pretty close together. So if we have a minus and a plus, then I could use a positive 8 and a negative 6 to put here and here, and that would make the middle term add up to positive 2, and that's correct. So notice that outer times outer is 8p, inner times inner is negative 6p, 8p minus 6p does make positive 2p, so this one's in good shape. Now, when the leading coefficient is different from 1, we can still factor using the same method we just saw, but we just have to make sure that outer plus inner adds up to whatever the middle term is. So you need to be careful and not fall into the trap of thinking that your two numbers are always going to add up to your middle term. They will not, but outer plus inner will add up to the middle term, and that's what you need to watch out for. Now also, before you start trying to reverse the FOIL process, always check to see if there is a GCF. And if there is a GCF, you need to factor it out first. You're going to have to factor it out at some point, and you may as well factor it out first so that the trinomial will be easier to work with. Okay, here we have a couple of trinomials to work on, and notice the instructions say factor each trinomial if possible. Here we have 3m squared plus 14m plus 8. Notice that nothing goes into 3 and 14 and 8. Nothing goes into all three of them. So we do not have a GCF here. And we can just start trying to find the two binomials that produce this trinomial. Now first times first is 3m squared. So that tells me that I could use a 3m here and a 1m here. And notice I didn't even write the 1. That's okay. But 3m times m does give us 3m squared. Now the signs that go here are based on this sign right here. This is a plus. So this tells me that these two signs must be the same. And if they're the same, they must be the same as this middle term. So I'm going to need two plus signs here. And then last times last has to be 8. So my choices for 8 are either 1 times 8 or 2 times 4. And just like putting together pieces of a jigsaw puzzle, you need to just stick the numbers in there, see if you get the right middle term, and if you do, then great, and if you don't, then rearrange and try again. So I'm going to start by just guessing. It's just a guess when you first start out. I'm going to start by guessing that my 8 is broken down into 4 times 2. Now, if I check my middle term, outer times outer is making 6m, and inner times inner is making 4m. And that's going to add up to 10m, which is not what I need. So I'm going to cross that out. And that just tells me that 4 and 2, they're either not the right numbers or they're just not in the right position. So the first thing I think I would do is just try changing positions. Let's put the 2 here and the 4 here. And now let's check outer plus inner again. Outer times outer is 12m, see that? And inner times inner is 2m. 12m plus 2m does add up to 14m. And so since we now have the right middle term, we now know this factoring is correct. But I'm going to go ahead and erase all of this work I've done in blue because I want to make sure that you understand that the answer is the factoring. The answer is not the little check work that we did down below. The answer that we were after is the factoring. Okay, now looking at part B, we have 6a squared minus 11a plus 4. And so we check for a GCF first. I have 6 and 11 and 4, and nothing goes into all three numbers. So that tells me I can go ahead and set down my two empty pairs of parentheses. Now, this one is maybe a little more complicated than the first one we worked on because 6a squared can be produced two different ways. 6a squared could be 3a times 2a, but it also could be 6a times 1a, and either could be correct, and you have no way of knowing which one is correct at first. You just have to pick two factors and work with them and see if they work, and if they don't, then you can change to the other two factors. I'm going to start by guessing that 6a squared is 3a times 2a. Remember, it's just a guess. If I can't get the right answer to work out, then what I'll do is I'll erase these and change it to 6a and 1a, but let's see what happens. Okay, now the signs need to be both the same because last times last is going to make a positive 4, so that tells me that these signs must be the same, and if they're the same, they both have to do whatever this is. So I need two minuses here. And then last times last has to make a 4. Now what are my choices for 4? Well, 4 could either be 1 times 4 or it could be 2 times 2. Notice what happens if we put in 2 times 2. I need to show you something important here. If you put in 2 and 2, then notice that this last parentheses contains a GCF. Okay? You see you could factor a 2 out of this parentheses. Well, we know that our original problem did not contain a GCF. And that means that our answer should also not contain a GCF. So without even adding up outer plus inner, I know this is not going to work. This is one combination that I can just strike off my list. So I'm going to go ahead and erase that. And instead of 2 times 2, I'm going to have to use 1 times 4. Now think about it. If I put the 4 here, notice that I'll have a GCF again because 2 and 4 can both be divided by 2. So I know the 4 can't go here. It's going to have to go here. And that means the 1 has to go here. And that's pretty much the only way it can work. But I still have to make sure that it does work because it's possible that this can't be factored at all. So let's check. Outer times outer would be negative 3a. Inner times inner would be negative 8a. Negative 3a plus negative 8a does add up to negative 11a, which is what we wanted. So this is the correct factoring, and we can just get rid of that scratch work. Now, if you're feeling a little overwhelmed here, remember that this is a learned skill that only comes with practice. So it's not any different really from tying shoes or braiding hair or making a free throw. It's just something that you have to practice over and over in order to really get good at it. So don't give up. Here are a couple more for us to work on. Here I have 12a to the third plus 10a squared minus 42a. Now these numbers seem really large. Also notice that a is common to every term. So when the numbers are larger than usual, you might want to ask yourself, is it possible that these numbers can all be divided by the same thing? In this case, it's definitely true that 12 and 10 and 42 can all be divided by 2. Also, as we said before, we have an a that's common to every term. So our GCF is 2a, and we'll need to look at the trinomial that we get from factoring out a GCF of 2a. Okay, 2a times 6a squared would produce this first term. 2a times 5a would produce the second term. And 2a times negative 21 would produce the last term. Check it out. Notice that if I distribute the 2a, it goes right back to this form. Also notice that now a is no longer common to all three terms, and nothing besides 1 goes into 6 and 5 and 21. So now we've removed the GCF. Now don't lose it. It does need to stay here, but it's just out of the way. So now we're going to break this trinomial down into the two binomials that produce this. And keep the 2a as part of your answer. See, my 2a GCF is right here, but I'm going to break this trinomial down into two binomials. Okay, here we have 6a squared. So again, I'm going to start by guessing that it should be broken down into 3a times 2a. Okay, last times last is going to produce a negative 21. So that tells me that the signs that go here and here need to be different. Now, we don't know at first whether the plus should go here or here. You just have to make a guess. Just put it somewhere. As long as you put down two different signs, we can get to the right answer. So now that we've got our two different signs here, let's think about the 21. Well, I know 21 is probably 7 times 3, but it could also be 1 times 21. So I'm going to start with the 7 times 3. Notice that I cannot put the 3 here, because if I put the 3 here, it's going to create a GCF with that first 3 there. So I'm going to put the 7 here and the 3 here. Now let's add up outer plus inner and see what we get. And this time we are hoping for a positive 5a. Okay, so outer times outer is going to be 9a. Inner times inner is going to be minus 14a. Now that's going to add up to negative 5a. That's not what we wanted, but it's a really good sign though, because we wanted positive 5a, but we got negative 5a. So it's good that we got the 5. And now it's easy to fix the sign. All we have to do is change the signs here. And if we change the signs, now outer times outer is going to be minus 9a. Inner times inner is going to be positive 14a, and that is going to add up to positive 5a like we wanted. So if you get the right number but the wrong sign, change the signs. And if you get the wrong number, change the numbers. But all we had to do here was change the signs, and now we're in good shape. I do want you to notice that 3 and 7 do not add up to 5 at all. But that's not what's important. What matters is that outer times outer and inner times inner will add up to positive 5a. And now I'm going to erase the scratch work that we did and leave this as our final answer. And now let's look at part D. Here we have 18x squared plus 15x minus 75. And again, these numbers are quite large, and so it makes me wonder if maybe there's not something that goes into all three. And if you think about it, well, 3 goes into all three of these numbers. So now ask yourself, does x need to be part of our GCF? Here I have an x squared, and here I have x, and then this last term does not contain an x. So x is not part of our GCF. So we'll just put down 3, and then we'll put down a place to fill in the trinomial, because we do need to look at the trinomial before we try to break down the trinomial into two binomials. Okay, 3 times 6x squared would produce this first term, 3 times 5x would produce this middle term, and 3 times negative 25 would produce that last term. Now see, this trinomial is going to be much easier to work with than this larger one. So now we're going to take our trinomial and break it down into two binomials. Don't lose your GCF. Make sure and keep the GCF there. Okay, now 6x squared is going to break down into 3x times 2x. And last times last has to make negative 25. That tells me that the signs in these parentheses need to be different. So I'm just going to go ahead and put down a minus and a plus. I don't know yet if I might have to put the plus here instead. I have no way of knowing that, but I just put down different signs at first. And now last times last is 25, so that's got to be either 1 times 25 or maybe 5 times 5. I'm going to start by guessing that it's 5 times 5, so I'm going to put 5s here and here. And now let's check our outer plus inner. We need outer plus inner to add up to positive 5x. So outer times outer is 15x. Inner times inner is minus 10x. Together those do add up to positive 5x, which is what we wanted. So that tells me this factoring is correct, and I'm just going to erase my scratch work. And there you go.